Okay, here we go. Keep the fire burning here. Practicing our moles to moles conversions again, and we're using this exact same setup. So as long as you know, as long as you know which one is the known, that means where you're starting from, and what you're looking for, that's called the unknown, you're in good shape. So, we've got a balanced equation here. Let's take a look at number 1. It says acetylene, also known as ethene, is used as a fuel in welding. Obviously, that's this stuff, because it's not oxygen, it's not CO2, and it's not water. This is going to be what we are starting from. This is going to be our known. How do we know that? It says right here, 1.8 moles of acetylene burns. What's it looking for? How many moles of oxygen are consumed? All right, so we've got a known, we've got an unknown. What are we looking for? How many moles of oxygen are consumed if we use 1.8 moles of this stuff, C2H2? All right. Obviously, the moles of C2H2, this is the known, so this is going to go on the bottom. Moles of C2H2. What we're looking for is moles of oxygen. This goes on the top. Balanced equation tells us the ratio right there. According to the equation, the coefficient next to the oxygen is 5, and next to acetylene is 2. So right there, it tells you the ratio. All you have to do is multiply across the top and divide by the bottom. So we're going to say 1.8 times 5, and we're going to divide that by 2. The answer we get is the moles of oxygen that are consumed when we do this, 4.5 moles of O2. And if you're checking, your units should tell you that you set this up right, because they should cancel. We'll leave you with the unit that you want. Okay. All right, we got the whole rhythm going here. Let's stick with it. All right, we've got two compounds here. We've got iron 2 sulfide is heated in oxygen, and it produces something called iron 3 oxide. We're not worried about the iron 3 oxide. What we are worried about is that the fact that 288 moles of this iron 2 sulfide reacts. That's going to be our known. What's the question looking for? Moles of oxygen. That's this stuff. Okay. So let's set it up. What's it asking for? How many moles of O2 are the equivalent of 288 moles of this stuff, iron 2 sulfide? All right. What we know goes on the bottom, moles of iron 2 sulfide. What we want goes on the top, moles of oxygen. According to the equation, the ratio next to the iron 2 sulfide is a 4. So we're going to put our 4 right there. The ratio next to the oxygen is a 7. This pen's kind of weird. I apologize. Let's make that look more like a 7. Sorry, everybody. So we're going to say 288. We're going to multiply that by 7. Divide that by 4. How many moles of oxygen are used? 504 moles. That's all you do. Once you get the rhythm, it goes pretty quick. Here's number 3. It says the following balanced equation represents a reaction that occurs when chromium metal is placed in a solution of tin 4-bromide. Be careful. You've got two kinds of bromine, tin bromide. You've got tin 4 and you've got tin 2. Let's be careful because the question is clearly asking for this version. So watch out. Don't get confused. It's easy to do. What's it asking? Well, it's telling us that our question is how many moles of this version SnBr2 are produced if we react 0.0825 moles of chromium. All right, what that tells us is that the chromium is our known. It tells us the moles of chromium is our known. Tells us the version of tin with the 2 in it is our unknown. So let's get there. Let's make sure we know what we're talking about. How many moles of this stuff? That's what we're looking for. What are we starting from? 0.0825 moles of chromium. That stuff. Okay. So we need the balanced ratio according to the equation. That means we're going to go from moles of chromium to moles of SnBr2, not 4. And it tells us the ratio right here, right there in the balanced equation. That's a 3, that's a 2. All right. So we're going to take 0.0825, we're going to multiply that by 3 and divide it by 2, and there's our answer, ladies and gentlemen. 0.124 moles, in this case, of SnBr2. This pen should get a new pen. If your pen is giving you a hard time like mine is giving me a hard time, get yourself a new pen. You'll be a lot happier. All right, last one. Okay, wow, what's going on here? Look at this. This is the last step in the production of platinum metal. Production of platinum metal means platinum metal is a product. We see it right here. The last step in the production of platinum metal, which is then used in catalytic converters in an automobile's exhaust system. We're not worried about that. This is how we're making the platinum that goes in there. It's shown by the following equation. So what it's asking is how many moles of platinum metal can be produced from 15 moles of this big clunky looking molecule here. And we're going to make this our known 15 moles of this guy. Boy, good thing we don't have to calculate the mass. Well, not yet. What's the question asking for? It's asking for moles of platinum metal. Let's use different colors. All right, so our unknown, what we're trying to find is how many moles of platinum metal can be produced if we use 15 moles of this big clunky thing. And we're not even going to worry about the name. We've got a known, we've got an unknown. What's it asking for? How many moles of platinum, that's this stuff, are the equivalent of 15 moles? All right, I got to try to write this without getting carpal tunnel syndrome. PTCl6. Okay. Oops, hang on a minute. Okay, sorry about that. Had a knock at the door. So we're asking how many moles of platinum metal can be produced from 15 moles of this big clunky thing with ammonium and platinum and chlorine. We're using the 15 moles as our known. The platinum is our unknown. So, oops. So I'm going to go from moles of my known, which in this case is this thing, moles of NH4 2PTCl6, to moles of our unknown, which is what we're trying to find in this case, platinum metal. Bingo, all we need is the ratio from the equation. And check this out. They both are 3. And that means if it's 3 to 3, it's also 1 to 1. That also means they cancel. And that means you're going to get the exact same amount, 15 moles of platinum. And that's all you do, ladies and gentlemen. I'll see you on the next one.